Okay, we've done the obligatory 1 minute wait time for everyone to join. So before we get started, we'd like to acknowledge the traditional custodians of the land that we're all meeting on, all spread out here throughout Australia, the Turrbal and Yagara people here in Meanjin, the Gadigal people of the Eora Nation, the Wurundjeri people of the Kulin Nation, and the Whadjuk Noongar people over in Perth. We pay our respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples joining us today. A little bit of housekeeping. For many businesses, we know electricity is one of the top 3 controllable operating expenses, and volatility in the market is making it hard to plan ahead. But there is good news. We have some clear and proven strategies to reduce exposure to rising prices, manage demand, and strengthen your operational resilience, which is exactly what we'll be talking about in today's session. I'm pleased to be joined by Landon Khan of SolSombra, who has a wealth of knowledge to share regarding energy strategy and renewables. And here at NettZero, we specialise in emissions reductions and reporting, and have a large neighbours team with a focus on the built environment emissions, as well as organisational emission strategy. So these 6 focus areas you see on the screen here will form a practical roadmap for improving energy performance, cutting costs, and building long-term energy security. So whether you're a building owner, a tenant, a facilities manager, or really anybody looking to cut costs and emissions, there will be something for you in today's session. We're going to walk through each one of these with some examples and some evidence-based advice and actionable steps you can take. Today's session will be recorded and we'll make that available afterwards, and we'll have a Q&A session at the end. So the chat is engaged. If you have questions, pop them in the chat and we'll get to them during the Q&A session. With that done, I'll pass over to Landon to introduce himself and jump into the juicy topic of lowering those energy bills.
Thanks very much for that introduction, Zach, and thanks everyone for joining. We're going to try to keep it really practical today, and starting with an understanding as to what is your biggest energy challenge. So we've got the list here of 10 different challenges. I'll go through it shortly, and then at the end of that, if you can pop into the chat the number that corresponds what you think your biggest energy challenge is. So we can have a bit of an insight what people are kind of playing with or dealing with it at the moment. So number 1, high energy bills. So costs are rising and it's impacting your margins. Number 2, lack of visibility or data. You don't know how or when you're using your power. Inefficient equipment or systems. Old equipment without a roadmap for upgrades. Difficulty identifying ROIs for upgrades. You're not really sure what's going to actually save you money. Low staff engagement or behavior change, so people are not getting involved in helping to reduce energy usage. You're unsure about renewables. You're interested in solar and batteries, but you don't really know where to start. No time or internal capacity to manage energy. You're just too stretched. Building certifications and performance, so improving environmental or energy credentials of your buildings. Compliance or reporting pressure, sustainability or financial compliance requirements, or split incentives or tenancy issues. So you're an asset owner, and so you're not really sure how to get the best value for energy efficiency or energy in your buildings. So if possible, choose your number 1 to 10, pop it in the chat. It'll be great to see and get an understanding what people are dealing with. Not mandatory, but good to understand what you're dealing with, so we can make sure that we hopefully cover some of that today. All right, so moving on. Here is another little quiz, but this is more of an individual quiz to give you a bit of an insight around where you are with lowering your bills. So it is, can you answer these 5 questions? So this, you're not going to respond, but just for your own sort of knowledge, is do you know your top 3 energy consuming systems? Are your energy costs flat, increasing, declining? Do you track your energy intensity? So kilowatt hours per meter squared or kilowatt hours per unit if you're producing something. Have you implemented any low cost or no cost efficiency solutions? And can you identify or quantify savings from past upgrades? So you can give yourself a score there. If it's 0 out of 5, then you've got a lot of room for improvement and opportunity. If it's 5 out of 5, that's great. But we're confident you'll still find value and there's still opportunities to further reduce your energy cost. So moving on. So it all starts with data. So these are two graphs from one business from an energy audit that we completed. And data really gives you the understanding and the ability to start to make changes and understand where you can impact your energy usage. So the graph on the left is 12 months monthly usage split into the various tariff structures for that business, overlaid with the solar that's being generated on that site. And then also the dark blue line is their max demand. So starting to build a picture of when and how much energy is being used on a monthly basis. And so with this insight moving forward, this business can now compare that as each month in the following year is provided to them. They can compare it to the previous year and see and start to identify, are there any discrepancies. On the right, it's 24 hours, so midnight to midnight, averaged over the 4 seasons. And so you can see the blue line is summer that peaks the highest, mostly because of HVAC, air conditioning. But something that's really interesting is you can see the green line, winter, pushes out a little bit to the right, a bit later than summer. So that's something that was identified that shouldn't necessarily be the case for this business, and then created the opportunity for them to investigate that as to why that was happening and was it something that they could impact and reduce and change. So moving on, here are 4 examples, again, from energy audits that we've recently completed of different businesses in different industries, with the insight of where they're actually using the majority of their energy. So top left, hospitality business, most of that is HVAC, is air conditioning, with the next highest being gaming machines. You compare that to the manufacturing on the top right, the vast majority, over 80%, is manufacturing. The retail on the bottom left is mostly HVAC and lighting, and then the medical on the bottom right is mostly medical equipment, with the next biggest being HVAC. And so what these start to illustrate is what we call the 70-30 rule. So moving on, if you can identify these 2 to 3 big systems within your organization that drive most of your energy usage, it's likely going to be around 70% of your energy usage. So similar to the 80-20, but often we find it is that sort of 70-30. You can then start to look at ways to materially impact your energy costs. So they're typically tied, as you saw, to operational activities, so air conditioning or production. And if you have analytics, or you can implement analytics to get access to these insights, you can then start to look at things like scheduling and smart controls to bring some of these down potentially. You couple that with staff training, which can further help to reduce that. And we often find that there's relatively simple initiatives around maintenance and operation that are not expensive to do, but can have significant savings. And we'll touch on some of that in a moment. And we suggest conducting energy audits semi-regularly. So we've seen outcomes of up to 60% reduction from the initiatives suggested, and even sort of overall paybacks under 2 years for those initiatives. And really important is to take advantage of grants and incentives that are available. So over the last 12 to 18 months, there's been quite a number of incentives or grants around the country. And just to give some examples, so in about February last year, there was the SME Energy Efficiency Grant, which was up to 25K to reduce energy costs. In South Australia, there was another energy efficiency grant up to 50% coverage and up to 50K. Under that, one of our clients got solar and storage at a 1.5-year payback, which is pretty impressive. And for example, currently there's one for Queensland manufacturers where you can get up to 50% of costs back on energy upgrades, energy efficiency initiatives. So moving on. So here are 2 case studies from businesses that we recently did energy audits for. So on the left, it was a hospitality business. They were spending almost $350,000 on energy per annum, open most of the day. And one of the findings was they were able to implement an additional temperature set point on their HVAC, on their air conditioning, in line with industry recommendations, which would deliver an 8% cost reduction, so about $28,000 per annum with zero cost, and instant payback. That was something really simple. That's probably the gold standard of initiatives that you might find. They were very pleased with that. But then we look on the right, a food manufacturer, so they were spending about $157,000 on energy, operating 6 a.m. to 10 p.m. And one of the findings for them was that there was significant initiatives through operations and maintenance on their core room that would improve insulation and efficiency. That would result in a 6% reduction, about $9K. Was going to cost about $10,000 to implement that, but almost a 1-year payback on that one. So there are often a lot of initiatives that come from energy audits that can really give significant benefits without having to spend huge sums of money. Moving on. And I will pass over here to you, Zach.
All right, thanks, Landon. We'll talk a bit about peak demand charges here. So at NettZero, we're privileged to look at thousands of energy bills each year. And so today we'll be discussing the troublesome phenomenon that is peak demand charges. So what are they? Well, when you look at your bill, go for a line called maximum demand charge, peak demand, kilowatts, or demand tariffs. These are charges based on your building or your tenancy's highest 15 or 30-minute electricity demand interval during the billing cycle. So it's not a time of use charge where prices go up when everybody else is drawing down the most power from the grid. And it's not about how much total energy you used. It's about how fast you used that energy and when. Energy companies will say that their systems are designed to handle your peak, not your average, and that this is a mechanism to recover those infrastructure costs. So even if it's just for a short period of time, as you can see in this graph here, these little green spikes here, those spikes determine a significant proportion of your total electricity bill. Is it a big deal? I think so, at least big relative to the rest of your energy consumption. This example here really illustrates how much impact peak pricing can have on your bill, even when your peak usage is tiny. So in the case of this building, using an average of 50,000 kilowatt hours over the course of a month, of that, only 150 kilowatt hours, just 0.3%, was used during their peak period. But now look at that cost. That 0.3% of energy made up a total of $1,125 of the bill. That's 7% of their electricity costs for 0.3% of their energy use. So despite being a tiny fraction, that peak usage is being charged at 7 times the cost per kilowatt hour compared to non-peak demand charges. So this is why it's really important to manage that peak usage and flatten the demand spikes out. It's not just about cutting your consumption, but as we can see here, there's some opportunities to avoid unnecessary costs. So how do we flatten this curve? There's a couple of strategies we'll talk about here. The first being load shifting. This essentially involves rescheduling high energy tasks to less busy times, like in the morning, overnight, or in weekends, depending on exactly what you're trying to do. So basically don't run all your high use equipment at the same time. That's just going to create a peak when you can spread it out over the course of a day. So by doing this load shifting, you're avoiding drawing those large loads when your internal network is already strained. The second strategy is to stagger your startup sequencing. So you come in the morning, your facility teams come in the morning, your first staff come in the morning, and we turn on everything all at once. Right? This can also be a great way to establish a demand peak. Instead, you want to stagger your startup equipment, especially stuff like HVAC pumps or lifts, and help flatten out that load curve. This can be automated by your building management system if you have one. Otherwise, you can implement it manually by your facility teams, depending on what level of control you have over the facility. Okay, this third strategy is battery storage and peak shaving. Essentially, this is battery systems like the one pictured on the slide that can discharge stored energy during those identified peak times. So this reduces your draw from the grid and helps you avoid those peak demand fees. And it's especially potent if you pair it with something like rooftop solar to maximize self-consumption of energy. If you've done some analysis and your BMS tells you, or you've done an energy audit, and you can tell when the usual energy peaks are, that's when you want to look at deploying that stored energy from your battery. So key takeaways here are that even without major capital investment, maybe in the case of a battery, you can still reduce your peak demand and associated costs through smart scheduling and a bit of automation there and spreading that load out throughout the day. And these strategies are pretty scalable for both building owners and tenants and give you really short payback periods with long-term savings. So beyond those strategic ideas, what else can we change in terms of tech, specifically smart monitoring and controls? Without smart monitoring, we say buildings operate blindly. They're heating, they're cooling, or lighting spaces regardless of the actual need. This leads to energy waste. You're air conditioning empty rooms, you're lighting empty rooms, which is also causing excess wear on equipment and missing opportunities for that load shifting we spoke about. According to neighbours, even well-performing buildings can save 10 to 20% of their energy just by tuning their schedules and tightening the control logic. The practical benefits are lowering your peak demand charges. So by automatically pre-cooling or preheating during off-peak times, you're spreading out that energy demand throughout the day and avoiding those peaks. You can also trigger alerts when approaching demand thresholds, depending on your BMS or energy reporting platform. You can reduce consumption by having real-time data to let you identify anomalies quickly. If something's running when it shouldn't be, or there was a scheduling mishap or a piece of faulty equipment, you can pick that out through your BMS or through your energy management system and quickly fix it as opposed to letting it run up that energy. You can also adjust your HVAC schedule seasonally or by occupancy and turn your lights on and off and adjust your plug loads in unused spaces. The benefits go beyond just energy savings though, and we'll look at equipment longevity in a little bit, but these smart controls can really help by detecting system inefficiencies. So you've got a fan running 24/7 when it shouldn't be running 24/7. You're able to identify that and address that through things like these management systems. It also prevents short cycling and overuse, especially for chillers and compressors, and will help reduce your maintenance costs through early fault detection, as opposed to something having a catastrophic failure and needing replacement. We can see it's drawing a bit more than it should. We should have it checked out and maybe give it a service. We'll look at a few use cases for each of these topics that I cover, this being a use case for a building owner. This building owner is a mid-sized commercial facility facing significant peak demand charges, so they've adopted a three-pronged approach. The first being the smart controls and scheduling we just spoke about. First, installed sub-meters on major systems and tenancies. We can all agree data is important. If you don't know where and what your energy is being spent on, you can't address it with strategies. So sub-metering is a really good way for commercial buildings to identify those spots. Programming the BMS to stagger HVAC startups and automate pre-cooling during off-peak periods. So we're spreading out that demand and getting the building cooled earlier. And integrating occupancy-based lighting controls in common areas. So again, if there's no one in that space, does it need to be lit? Okay, let's install some sensors in there to make sure that we're only drawing power when someone's actually using the space. They also installed a 100 kilowatt hour lithium ion battery connected to their rooftop solar array and programmed it to discharge during daily peak periods of 2 p.m. to 6 p.m. to offset their grid load. Resulting in a 16% reduction in peak demand, saving $14,500 a year in demand charges, which is pretty good. They cut their total daytime grid draw by 20%, probably more during the summer months, and reduced their scope 2 emissions by 60 tonnes per year. The battery return on investment was projected at 5.5 years after some New South Wales incentives and avoided charges. So it's a pretty good case. Not everyone owns a building though, some people just work in them. So this case is a 500-person tenant. They'd seen high after-hours energy use and unpredictable peak loads, partially due to cleaning and IT equipment running late into the evening. So to kind of bring themselves in alignment with some broader efforts in the building and try and reduce their energy consumption and emissions, they worked with their facilities teams to analyse their tenancy sub-meter data and identify those energy hotspots, and adjusted cleaning times to the mornings to avoid the HVAC running on overnight. So bringing in the cleaning team during that pre-cooling period, and then they can shut it off earlier. They installed smart power strips and timers on AV and kitchen equipment, which allowed them to do stuff like energy curfew policies, where at 7 o'clock or 8 o'clock or wherever it might be, those actually get turned off at the point, so they're not having machinery running on standby for 12 hours overnight when no one's in the office. And they ensured that their staff's laptops, monitors, and printers were powered down at the end of the workday. This helped reduce their tenancy peak load by 8% and cut annual electricity costs by $9,600. This also helped improve their neighbours' tenancy rating and contributed to broader corporate sustainability goals. I'll pass back over to Landon to discuss a bit about protecting against price volatility.
Thanks, Zach. All right. So if you want to flick to the next slide. Fantastic. Thank you. So here we have 4 graphs that the wholesale energy costs from the national electricity markets in New South Wales, Victoria, Queensland, and South Australia over the last 12 months. And we've highlighted 2 intervals in each of the graphs. And you can see there's peaks in each of these intervals. And so what are these times? It's end of the financial year and end of the calendar year. And these are times often when businesses recontract. And so what that means is you're going to recontract, rates increase, and then you contract for potentially 1, 2, 3 years at a higher rate than maybe shortly after then or shortly earlier. And so this can mean potentially, over a 3-year contract, tens of thousands of dollars difference. For one client, it looked at about $30,000 over the 3 years. So that is a significant amount of money. And so volatility is a big issue when it comes to pricing. So moving forward and moving on, businesses, unfortunately, are generally price takers when it comes to electricity. We're at the whim of the current market, and this is being locked in for a period of time. Networks also tend to change their structures and timing, which can make things confusing. But being able to take control of your energy presents an opportunity to hedge against these increases. And so the first thing is understanding your contracts and tariffs and aligning business activities with these. So, Zach's mentioned starting things earlier, using off-peak, etc. So when possible, looking at renewables, energy efficiency, and load controls. And so that helps to mitigate against some of the large increases that we're seeing for clients at the moment. And also stay on top of your demand charges, exactly as Zach mentioned. And one of the things that we often see is a lot of clients, they don't have great power factor, and that can be simply remedied with some power factor correction, which generally delivers a pretty good return on investment. So moving on. Here we have a graph from one of our clients. Again, is the 24 hours, their load profile over the 4 different parts of the year. And this red line is an artificial line. So that is where their load would be without solar. But the load is actually significantly lower because solar is generating throughout the day, and they're effectively controlling that energy now. And so that presents a pretty significant difference for this business because they're not necessarily impacted by market conditions for a large chunk of their daytime usage. And then there's the ability to add storage onto this. So moving forward. So solar is one of the key things. A lot of businesses have considered solar. The penetration of solar in businesses is a lot lower than homes, so likely less than 10% compared to over 40 with homes. And then storage is even significantly lower than that. So this table here is a real-world payback for a 100 kilowatt system for a client at approximately 4.5 years at a cost of just under $100,000. And generally the paybacks are 3 to 5 years for solar only and sort of 4 to 8 with storage as well. But you can also explore on-site solar, but also off-site renewables as well as a path to 100% renewable coverage and long-term energy price security. This can be done through no capex options such as power purchase agreements. And so they are becoming a lot more popular in Australia. So in the US, majority of commercial solar has been done on power purchase agreements. Australia, it's a much smaller percentage, but it is becoming more popular. And take advantage again of subsidies or rebates. So in Victoria, the VEEC subsidy, the VEU, makes commercial solar a lot more attractive, even than using the federal subsidy of LGCs. So understanding that and taking advantage when those are at a high volume. Next slide. So energy security and independence. So coupled with solar is storage. So if we move on. So energy security and independence isn't just about savings. It's also actually about resilience, continuity, and control. We saw with Cyclone Alfred recently how that significantly impacted the areas affected. Also look to reduce dependency on gas, so things like hot water and electrification. This can give you greater control over price and future emissions benefits as more renewables come online. The energy that you use, even if it's just from the grid, is going to continue to be more and more green or with reduced emissions factors. Greater analytics, as I've kind of mentioned, can allow you to start to prioritize loads and put in place strategies for blackouts or brownouts. And then coupling that with smart controls, you can actually automate critical load shedding as well. One of the interesting things for businesses to consider is around EVs. So EVs can significantly impact your energy usage and costs if those are being charged on site. And so one of our clients is looking at a 6% increase in their energy usage with only 5 electric vans coming into their fleet. So as mentioned, energy storage is the real key to true energy security and independence, but it generally doesn't come cheap, or does it? So moving on. So at the moment, everyone's talking about energy storage. Jan, she doesn't like energy storage. She is a solar panel, but solar and energy storage go hand in hand together. So moving on. So typically the paybacks have been pretty unattractive, 8 years plus, with the capital cost very high. And that's one of the key reasons why there's been limited penetration. But that tide is most certainly changing. Labor over the weekend, for example, they came out with a policy, a new battery rebate for homes and small businesses. They spoke about 50 to 100 kilowatt hours of storage being given a subsidy of up to 30%. The details are a little bit ambiguous at the moment, but if they are re-elected, that can significantly change the attractiveness for batteries. And then on top of that, being able to access more value from the energy or having a battery on site, that the full value stack is making the business cases significantly more attractive. So if we move on, we've got some real world case studies. So this is a manufacturer, and they looked at 500 kilowatt hours of storage. So the top one, you can see an upfront cost of about $575,000, savings of $118,000 in year one, which would deliver a simple payback of 5 years, which is for storage is pretty good. But then you actually start to look at that on a finance arrangement. So there's no upfront cost. The cash flow in year one is much lower, so $4,000 in savings. But if you look to the net present value, so the savings, the financial return over time, it's not that dissimilar from the CapEx arrangement. And so this is something that we're seeing a lot of businesses starting to look at, is looking at finance solutions for batteries. And also taking advantage of demand response revenue, FCAS revenue, and really getting a lot more benefit from having a battery on site, as well as having standalone or power available almost at any moment. So moving on. Here we go into a little bit more insight around what that actually means for the business. So the graph on the left is what is the likelihood of backup power being available for this business at any given point in time throughout the year. So the purple line is what percentage of the year would 30 minutes of backup power be available. And so it's almost 100% throughout the entire year. The line below that is an hour worth of power, so it's around about 80%. Then 2 hours is about 50% throughout the year. And this is backing up the entire site. So if you were only to back up critical loads, then those percentages would significantly increase. The graph on the right shows the load profile of the business. So the grey line is the load before they would implement the battery. The blue line is what the load would look like after the battery. And then the red line is the percentage of power or the state of charge of the battery throughout the 24-hour period. And so you can see that something really interesting, at about 6 p.m., the load of the site actually goes negative. And what that's basically meaning is that battery is trading energy on the wholesale market. So when the wholesale price peaks, which is generally sort of that peak period after people get home, put on their air conditioning, that side is actually trading energy and making significant revenue from that. You can also see the carbon or the sustainability benefits as well. So moving on to a different case study. So a medical company, they looked at adding some, they've already got some solar. They looked at some additional solar and a 250 kilowatt hour battery. So that's about just over 300K. Similar payback around 5 years. But again, looking at that financed, so the payback or the return that they're getting, the net present value, again, pretty attractive in comparison to the capex. So it just shows that if you have solar on site, but storage is never stacked up for you, now is the time to really look at it and look at some of the full value stack and finance solutions, because it may make it significantly more attractive. So if we move on to the next slide, again, these are the two same graphs, and you can see this is showing on the left what percentage this would cover for the business of 30 minutes of standby power. Again, it's pretty much 100%, and then cascading down 1 hour, 2, 4, etc. But again, you would never look to, in this circumstance, do the whole site. You would probably look to cover critical loads and then potentially extend that, or maybe potentially do a waterfall approach. Again, on the right, you can see the comparison of the load before the battery or after implementing the battery. Here you have the yellow line is the solar generation on top of the battery as well. So moving on. And I'll hand back over to you, Zach.
Thanks, Landon. Man, batteries are getting really cool. It's pretty exciting what the possibilities are when combined with rooftop solar and then electric vehicles as well. I think we'll be seeing a lot more of these in the very near future. Okay, so moving back over to more energy efficiency stuff, I guess from a facilities and operations side of things. Equipment, right? Equipment uses energy. Energy costs money, but equipment itself also costs money to repair and to replace. So we'll take a look at some of the ways we can control those costs by ensuring that our equipment is running efficiently. So poorly maintained or outdated equipment, it's not just an energy drain, it's got cascading operational impacts that'll affect your bottom line, your workforce, and your environmental performance. Older motors, older pumps, and lighting systems will often run hotter, especially if they're operating at fixed speeds or in a perpetual state of overload. Heat is the #1 enemy of electrical components, and Australia gets pretty hot, right? So high operating temperatures will degrade insulation, bearings, and electronic control boards, shortening your component's lifespan and significantly increasing the replacement costs. Poor ventilation or lack of maintenance, so clogged filters, uncalibrated sensors, this stuff makes the degradation even worse, which leads to a vicious cycle of inefficiency, feeding degradation, feeding more inefficiency, feeding degradation, and then the thing breaks and you've got to replace it. So inefficient systems will draw more current, they'll run longer and work harder to achieve the same output, driving up your energy bills, but also increasing maintenance frequency and having those higher servicing costs, especially for reactive callouts during faults. When that cycle breaks and the piece of equipment fails, you need to call someone out, pretty quickly if it's a crucial piece of equipment, and that's not cheap. So a poorly tuned HVAC system, just as an example, can easily cost 10 to 20% more to run and still underperform in comfort delivery compared to a newer, more efficient model. In contrast, upgrading to energy efficient equipment can double your expected lifespan while reducing usage hours through some of those smarter control integrations that I spoke about earlier. HVAC typically accounts for 40 to 60% of energy use in commercial office buildings in Australia, especially in larger or older assets. The most impactful upgrade you can make is switching to high efficiency variable speed units or variable speed drives, VSDs. What is a VSD? Basically, instead of something operating at 100% capacity when it's turned on and 0% capacity when it's turned off, VSDs can ramp up and down based on real-time temperature and load requirements to help avoid energy spikes and reduce wear and tear while maintaining occupant comfort more efficiently. So think of it as a dimmer control for a fan, and buildings tend to have lots of fans, although you don't see too many of them. VSDs can offer up to a 40% reduction in HVAC energy use, which is significant. It can help reduce your peak demand contribution, and a lot of them will qualify for New South Wales energy saving schemes incentives. Full VSD upgrades can also help improve your neighbour's energy rating, maybe by half a star to a full star, depending on baseline performance. VSDs also have a life cycle bonus for your equipment. The lower runtime and better control means fewer breakdowns and longer life for compressors and fans. Many base building systems still rely on fixed speed motors and legacy fans that run at full tilt regardless of demand. Under Australian law, new commercial motors and appliances will have to meet minimum energy performance standards, or MEPS. So upgrading to these MEPS compliance or high efficiency models can offer a 15 to 30% energy savings per unit. They have less noise, vibration, and heat generation, which means reduced operating temperatures and less cooling load. So when you're looking at some of these upgrades, check out your chilled and hot water pumps, cooling tower fans, supply and return air fans, and your kitchen exhaust and car park ventilation motors. So these kind of unglamorous, often forgotten about areas that tend to have the most inefficient equipment in there, so they're always worth a look if you're considering an upgrade. If you're in a tenancy and your building still has halogens, fluorescents, or CFLs, it's time to ask for an LED lighting upgrade. LEDs use up to 80% less energy and last 10 to 5 times longer, reducing your replacement costs. They're also safer, so there's no mercury or excessive heat output from LEDs. I've never burnt myself on an LED. I've definitely burnt myself on an old halogen lamp, and they've got better light quality and dimmability, so you've got more control over how that energy is deployed to the LED. So if you're thinking about implementation, consider prioritizing high usage zones, plant rooms, lobbies, car parks, bathrooms, and common areas, and review your operating schedules as part of the upgrade. Many systems you'll find run longer than needed and can be tapered down. Integrate sensors into your upgrade as well, so occupancy, daylight, and CO2 sensors will help you automate lights and HVAC systems. And for neighbours rated sites, track your before and after kilowatt hours per square metre energy intensity and really quantify that improvement. Little case from a building owner. It's our same commercial office. They replaced all lights with efficient LEDs, swapped out 8 old HVAC units with VSD drive and recalibrated zoning control units, replaced their inefficient cooling towers with new MEPS compliant motor ones, and installed motion and daylight sensors in their back of house and plant areas. This helped them reduce total energy consumption by 19% and saved 48 grand a year in energy cost plus 6 grand a year just in maintenance. The return on investment for the full upgrade was a bit over 2.5 years, and they helped to reduce their Scope 2 emissions by 85 tonnes per year, with a neighbours bump from 3.5 to 4.5 stars for energy. Again, for our tenants out there, there's still stuff you can do with only limited operational control, particularly that LED lighting upgrade. You can also swap out all your inefficient old computer monitors and computer towers for Energy Star rated laptops and monitors. Those smart power strips and smart plugs, you plug them into the wall, you can control them from your phone or your tablet and schedule things to turn on and off, which will help with things like an auto shutdown or a power cutoff policy. In this case, it helped drop their lighting load by 65%. Like I said, those LEDs are really efficient, and those smart plugs help reduce plug load consumption by 18%. This gave annual electricity savings of $16,500 and a 35-tonne Scope 2 emissions reductions with a payback on investment of 1.5 years. So energy optimization doesn't stop at HVAC systems and lighting. There's also a lot to be said for the building envelope that extends into how your space responds to heat, airflow, light, and occupancy. There are passive and semi-passive strategies that can significantly reduce the energy load on your systems, lower your operating costs, and improve the thermal comfort with minimal ongoing input. We often focus on those mechanical systems, but your envelope, so your walls, roof, windows, and doors, all play a huge role in how much heating or cooling your building actually needs. If you're constantly losing conditioned air through poorly sealed envelope, your HVAC is fighting a losing battle. So some key actions to consider are upgrading or adding roof insulation, especially in older buildings that may have degraded or minimal coverage. Sealing gaps around your windows, doors, and surface penetrations, which are often culprits behind hot or cold spots, and insulating exposed pipework and ducting in ceiling spaces and plant rooms. Again, these forgotten areas aren't very glamorous, but they do contribute significantly to system inefficiencies, especially for larger commercial facilities. Pardon me. The benefits of doing this are threefold. First, you're reducing your thermal loss and unwanted heat gain all year round, which directly cuts down your HVAC demand. Second, it allows your systems to operate more efficiently and cycle less frequently, meaning less wear and tear and lower maintenance and replacement costs. And finally, you can improve your neighbours' indoor environment scores, which many tenants value highly in premium grade spaces, especially in this post-COVID world. Talking too much. In terms of savings, these upgrades can deliver 10 to 15% reductions in energy use, especially in buildings. If you've got a poor baseline for performance, that's when you'll see the most gains. In New South Wales, a lot of these works may also be eligible for energy saving scheme incentives, depending on the materials you use and how they're applied. East and west facing facades are particularly vulnerable to heat gain entry. In the morning and the late afternoon, when sunlight comes in at a low angle, it delivers concentrated heat load through the glass. This will overheat your perimeter zones, especially during summer, and force your HVAC to work a lot harder. Even though glazing helps, not every building is in a position to replace all its windows outright. So we'll highlight some effective but pretty simple upgrades, such as external or internal shading devices, so blinds, awnings, fins, or vertical louvers. These are often quick little retrofits that can be tailored to your facade orientation. So is reflective window films. So these are really cost effective and reduce both solar gain and glare, which is especially useful if you have a lot of screen use. You don't want that glare. For buildings undergoing refurbishments, consider upgrading to a high performance glazing, double or triple glazing with low E coatings. This will reduce your air conditioning loads, especially during summer, help with thermal comfort, especially in open plan or glass heavy offices, and importantly, it can allow more daylight into the building without excessive glare or heat. Okay, many energy inefficiencies in leased spaces in particular don't come from the equipment itself, but from how the space is configured. So some practical low cost considerations are positioning your high load equipment like server racks, printers, and other plug loads away from windows and direct sunlight. This will reduce additional cooling demand and keep sensitive equipment running more efficiently. Second, be mindful of airflow. It's common for tenants to unintentionally block return air vents with storage units, large furniture, or partition walls, which will reduce your HVAC efficiency and can cause localized hot or cold spots. Third, layout and finishes matter. Use modular partitions that allow airflow and natural light to pass through, and choose a light-colored finish to reflect daylight deeper into the space. This will help reduce reliance on artificial light and improve visual comfort for staff. And finally, when selecting appliances and devices, always choose low energy rated options. Where possible, install sub-metering to track energy use by floor, team, or function, and this will give you a better visibility and control over where that energy is going. And it's incredibly helpful if you're aiming to improve your neighbour's tenancy rating or just reporting on Scope 2 emissions. Here's a little pyramid, I guess, that's a nice way to sum up a lot of what we've spoken about. Landon and I can both agree that data and analytics is always the starting point. You always need to know where your energy is being used, what's chewing up your energy and how much. Without this, you can't make decisions and strategize about making improvements. Then you've got your low-cost technology. This is a really good way to we call it the low-hanging fruit, but it's essentially stuff that's pretty accessible that maybe you should have done a while ago, and now you're getting to the point where we're replacing some of that older equipment. Things like LEDs, they're pretty cheap, but you get massive energy saving returns on them. Renewable energies as well, reducing that grid reliance on grid electricity, being able to generate your own, maybe store some of it. This makes a massive difference, especially if you're emissions reporting and you want to cut down on your Scope 2 emissions. And at the top of the pyramid here, we've got behavioral, right? So you can have the best tech, you can have the best strategies, but if staff aren't using them to their full potential, you'll never see all the gains that you could possibly make. So ensuring that everyone understands what the strategy is and how to best implement it will ensure that you get the best bang from your buck investing in all of these lower tiers on the pyramid. So with that said and done, we'll move on to the Q&A section of the session. We might have a question or two in the chat. Otherwise, if you do have a question, please use the raise hand function and we'll unmute your microphone and you can fire away. Otherwise, feel free to drop questions into the Q&A or just straight into the chat.
Zach and Landon, I got a question from a person who wasn't able to attend today. So I'll just kick us off with that one, if that's all right. Question is, what government grants or incentives are available to support energy reduction? That's probably a you question, Landon.
Sure, thank you. So this is being recorded, so they'll be able to see, right? Yeah, all right, excellent.
Yes. Yep.
So there's different grants and incentives that pop up all the time. Unfortunately, there's not one source that has everything. It is something at SolSombra that we have our finger on the pulse. And if and when these grants or incentives come out, we tell clients that, hey, this is potentially available for yourself. Is it of something of interest? And then help them along that process. I mentioned earlier there's a Queensland manufacturing grant currently. So if there's any Queensland manufacturers out there, it's up to 50% on energy upgrades or energy action plans. Probably one of the biggest things at the moment is just the solar rebate or solar incentives, energy saving incentives as well. So they're not grants, but they are incentives or subsidies. And so we would just suggest to stay aware of what's happening. And if and when opportunities come, you do actually have to move relatively quickly, because often it's such an area that's so important to businesses. There's huge demand and they often actually get exhausted a lot quicker than expected. So as an example, again, I mentioned last year the federal SME energy efficiency grants. Most of those were exhausted within 36 to 48 hours of them being released.
That is quick, isn't it? So you really do have to have your finger on the pulse.
Yes.
Got another one. What is the role of the BMS, a building management system, in improving efficiency? I'm guessing that one's an Atif, Zach kind of question. Atif?
Yep, I can take that one. So a building management system is very important just to improve the efficiency in your building. It can control everything from your lighting to your HVAC. And just sort of improves the energy usage and sort of reduces your electricity bill as well over time. So there's certain ways, there's a couple of aspects to it as well. So if it's connected to your HVAC equipment, such as your chillers, it can do what's called chiller staging. So both your chillers, or if you have multiple chillers, they don't all need to run at the same time. If you don't have a BMS system, they might already be doing that, which consumes a lot more electricity. The BMS may also have an optimization strategy where you look at temperature first thing in the morning. Normally chillers take about 1 to 2 hours to cool down the building. But for example, if the outside air temperature is already at a relatively stable, comfortable level, then your chillers do not need to have that 2-hour startup time, and you can end up saving a lot more electricity. However, overall, with the good BMS system, it can also control your lighting as well, so it can automatically switch off your lighting in the building after hours as well. So you would estimate to save about 10 to 20% of electricity in a year with a good BMS system.
Okay, thanks, Atif. I have another one, and Landon, this might be you, but can smart controls prioritize and shed non-critical loads automatically during blackouts or brownouts?
Yes, it is possible to do that, and Atif and Zach, feel free to jump in at any point. So ultimately, if you have a blackout and you don't have any power supply on site, the site is going to go down. So that's the first thing that you kind of need to look at. But if you have a generator or some form of standby power, then yes, having smart controls that can effectively, from a waterfall point of view, say these are the most critical loads. So if, say, for example, you are a food manufacturer and your cold storage is the most important, then that stays on first. If there is more power available, then it would waterfall down to the next equipment. But certainly that is something that we would recommend for companies looking at strategies to prevent going completely offline with blackouts or brownouts.
And maybe another one for you, Atif. Can tenants actually improve their neighbours' ratings if the base building is actually not as efficient as it could be?
That's a very good question. They absolutely can. So a neighbor's tenancy rating would be related to tenancy, light and power mostly. So that would be lighting in your tenancy and what kind of appliances and equipment you've connected within your tenancy as well. HVAC loads in most cases are outside the scope of a tenancy rating unless you have a special tenant requirement where you've got a boardroom or you've got meeting rooms and you have to put a special pack unit or air conditioning units that are servicing just that space. However, Zach in the previous slides has talked about quite a few initiatives that you can use to reduce the light and power loads in your tenancy. This might be simple, small, low-cost initiatives such as installing smart metering or smart electrical cords that sort of like switch off your equipment when it's not in use. And also using lighting upgrades and installing sensors and LEDs that would also impact your neighbor's rating as well. So there's quite a few initiatives that that you can implement on site, and yes, they would be independent of the base building rating itself.
Okay, that's good to know. You're not out of options if you are a tenant.
Yes, we've got a wonderful team at NettZero as well. We've got a whole team of neighbors assessors if you're looking to get a tenancy rating done, and we can sort of guide you through that process as well.
Now, just double check if there's anyone on the call that has any other questions. I have two more if we can fit them in, but anyone on the call have any other questions? No. Okay, I'll just ask, there's two more. This one's kind of a tactical one. Again, maybe for you, Atif.
We do have a hand up. Sorry, Marita.
Oh, we do? Oh, yay.
I'll
Holly.
throw over to Holly. I'll just turn your mic on there for you. If I can. You might just need to still unmute yourself on your device as well. There you are. Hello.
Hello, how you going?
Good, thanks.
I'm interested. I know there's been a lot of talk about obviously solar in this conversation, batteries, using solar on site. We have solar in various of our sites. Obviously, you're aware of that. I'm quite interested. There was a bit of talk before about obviously going back to the retailers as well, different times to get better rates moving forward. I kind of want to know if anyone's got any detail or feedback on the solar buyback. More so over the couple of years, we used to be able to get a good rate for solar buyback when it would go back to the grid. And now that has really dropped off in the last, I'd say 2-3 years. Some states are even refusing to actually offer you anything for the buyback. I don't know if anyone's could shed some light or has got any information on where that's kind of heading or what you're seeing. But no matter what, we're going to have excess solar, even depending on if we do put batteries on, that's only going to store so much. So I'm just interested in seeing, okay, where's that going in the future? What's some alternatives, or what can be done with that about the solar that we're producing, not being able to use, and then we can't treat that as green energy going back to the grid because then someone else purchases it as green energy. So I'm just kind of interested in what, if anyone has any ideas, what's going to happen for the future of that.
You want to have a crack at that one, Landon?
Sure. Yes, in a commercial sense, there is no feed-in tariff that's mandated. Residentially, different states have different mandates around feed-in tariffs, but they're also reducing residentially as well. When we look at business cases for solar, we don't include any revenue from a feed-in point of view. So it is likely that that's going to continue, that it will continue to reduce or not be offered at all. There has been some conjecture around a solar tax, so feeding in actually being taxed to feed in because of the impact on the grid. So we have what's called the duck curve, where there's effectively negative demand during the peak solar generation hours because we've got so much solar in the system, and then once the solar comes off, it really spikes up. You spoke about storage, so yes, that is probably the number one option for you to look at to store that energy and then use it at another time. Depending, I don't know anything about your operations, but you should be able to get storage that can store the vast majority of that. And the efficiency of storage from a space point of view has definitely improved over the last little while. And the other thing I would say is there are other sort of innovative trading or finance solutions that are now available. So you can do some peer-to-peer trading and various things with some retailers, but it does kind of restrict you to those retailers. But as well, you could also kind of look at around your load and trying to kind of doing the reverse that Zach and I have spoken about in terms of load shedding, actually trying to bring on load during that time to make sure that you're not exporting as best as possible.
Yeah, great. All right, perfect. Thank you.
Yeah, great question.
Right.
Well, we're just about out of time, so if you've got any more last-ditch questions, get your hand up now. Otherwise, Marita, we might throw back to you if you've got one more, and then we'll wrap this thing up.
One more, just a quick simple one might be, does moving to laptops instead of desktops actually make a difference? Might be a quick one.
Yeah, it does. I think depending on what model of laptop you get like a 25 to 50% efficiency gain versus an old tower desktop computer. So if you can imagine a tenancy with 500 staff, I don't think there's too many left that use all desktop towers, but using those at hours plus a day, there's a considerable energy efficiency gain there by switching to laptops. So yes, they're a lot more efficient.
Wrap then from questions.
Wonderful. Okay. Here's our contact details and what we generally specialize in. If you'd like to reach out to either of us, we'd love that. Landon here on the expert on energy audits and assessments, strategies and procurement, as we've learned solar and battery strategy, and electric vehicles. We ran a previous webinar where we talked everything EV. So if you're interested, we can send you the recording of that as well. And then over here at NettZero, energy efficiency upgrades, emissions reporting, which we didn't talk about a lot, but emissions reporting and decarbonisation, obviously neighbours ratings, and emissions offsetting as well. So if you're interested in any of those, you've got a project in mind or have got any other questions you think of after the session's ended, feel free to give us a call or shoot us an email and we'd love to get back to you. Any final remarks, Landon, Marita? Otherwise,
No, thank you very much for everyone for your time. As Zach said, feel free to reach out with any questions, and just wishing everyone well on the journey of energy and emissions reduction.
Great. Thank you very much, everyone. Enjoy the rest of your day.
Cheers.